So I'm Richard Ellis. I'm an astronomer, a professional astronomer. I work at the California Institute of Technology in Pasadena, California. So when we say cosmology, we're studying, the entire universe as a whole. How old is it? How big is it? How does it change? And we believe the universe began a long, long time ago, about 14 billion years ago, with a Big Bang, and that the universe is expanding. And so within this expanding universe, there's evolution. Galaxies form, stars form, they live and die and explode, and of course life eventually forms and evolves too. So cosmology sets the very biggest questions. What's the nature of the universe on the very largest scales? What's its future? Will it keep expanding forever? Will it eventually stop expanding and contract back in again? These are questions that are very simple, but we're still trying to answer them. And I think the enjoyment is that we can actually observe directly the past. So when we use a big telescope, we look deep in the universe. We're looking back in time because the light rays have taken so long to reach us. So we're able to time slice the universe. So we can directly observe the history of the universe with our big telescopes. So right now we can look back to when the universe was about 3% of its present age, when it was about 300 million years old. The universe is about 3 times older than the Sun, and we're now looking back 97% of the way back to the beginning. Yeah, so pretty well got the whole thing mapped almost. As you may know, the most powerful telescope that we have is called the Hubble Space Telescope. This is a space telescope orbiting the Earth. It's about 200 miles up, and it goes around the Earth every 40 minutes. And I built a team up that applied for 128 orbits, so that's 128 exposures of one very tiny area of sky called the deep field, or the ultra-deep field. And we got the deepest image yet of the universe that enabled us to look to very great distances. And the discovery that we made last year with this image was that we found new population of galaxies in the early universe, when the universe was about 300 million years old. This is the furthest back we've looked. And the properties of these galaxies tell us that we're not yet at the beginning. These are not necessarily the very first galaxies. So there's even more hard work to be done in exploring the universe at even earlier times. Although astronomy is fascinating and many people may be enchanted by the night sky, to become a professional astrophysicist you have to be a good mathematician and a good physicist. So the most important thing to get going is to get support from teachers so that you can be qualified in those subjects. I think it's very important that you enjoy astronomy. I think that comes without saying. And then, of course, getting to university is crucial. And the good news is there are many universities now that specialize in astronomy. It's so much more popular now in universities than it was in the 1960s, including here at Warwick.